Hi, my name's Jared Woolsey with my partner David Stutz, and our project was heat transfer through insulating materials. We actually decided to test two different insulating materials, a styrofoam cooler and a lunch cooler. We'll go a little bit more into the procedure a little bit later, but basically what we were doing is we were measuring the mass flow rate of how quick ice melted. For our experiment, like I said before, we had two different containers, a styrofoam cooler and a lunch cooler. After obtaining the two containers, we were able to attach four different thermocouples. One was to measure the outside air temperature, one was to measure the inside air temperature, one was to measure the inside surface temperature, and one was also to measure the outside surface temperature. After we had attached all these thermocouples, we filled the cooler with water and ice, and we were stirring it constantly until the water reached an equilibrium temperature. At which point the excess ice was taken out and was poured down the drain. We then took out a new piece of ice and weighed it, and then we put it in the water and closed the lid. We allowed it to sit for about 5 minutes, and then we opened the lid and took the ice out and measured the new mass of the ice. After measuring the new mass of the ice, we were able to calculate the mass flow rate. This experiment was repeated 2 more times for a total of 3 experiments for each container.
We made a few assumptions for this project, mostly dealing with the convection and conduction coefficients. First, we assumed that both the convection coefficients were just going to be from free convection, and we were able to calculate the H value for the outside using the Rayleigh's number and then getting the Nusselt number and then finding H. However, it was a little bit more complicated with the water. We kept getting a negative beta, so we just decided to assume that the H value would be about 50. And then when we went in to look for the K value for the cooler online, we couldn't find any of the material properties or anything. So we just had to kind of guess what we would use for a K value, and we thought it would be about 0.05. This is just a collection of all the data that we had to measure. The temperatures are all at the average temperature that we found them as we were doing the experiment in each case. So the temperature of the surface was the average of the temperature of the surface in each of the cases. Then what we also did was we measured the wall thicknesses and the lengths and everything so we could calculate the areas. In order to calculate our analytical mass flow rate, how quickly the ice was melting, we just used an energy balance equation with m dot HFG is just our E stored, and then that was equal to our 2 convections and our conduction. We assumed that the conduction cross-sectional area was just going to be the outside surface area, and we were able to use this equation to find our m dot both for the styrofoam and for the lunch cooler.
This data table presents the results that we saw in our experimental trials. As you can see, from trial 3, our MDOT was kind of an outlier. We attribute this to maybe not having zipped the cooler up all the way to maximize the cool air that stayed in. And we also took the average MDOT and for the cooler we threw out that last one because we decided that that wasn't a viable experiment. But other than that, they all turned out to be fairly close, and we believe that they were fairly accurate experiment.
In the end, we found that the styrofoam container was a much better insulator than the insulating cooler. However, we also found that the insulating cooler gave a lot more accurate data than the styrofoam container. We were a lot closer in that range. However, we thought of some things that we could have done better in the experiment that may have helped those values come closer. One of them was the ice, when we took it out of the container, it was hard to try and get all the water off of the ice because the water likes to stick to the ice, right? So trying to dry it off, we didn't do a good enough job there. And so when we weighed it, we weighed not only the ice, but we weighed a little bit of the water as well. Another thing that we could have done better with was getting a better H value for the inside between the water and the container. And also it would have been nice to have the actual K value for the insulating material. It just would have made our calculations a little bit more correct. But all in all, the styrofoam container is going to be a better insulator than the cooler. And this was to be expected because it just was a lot thicker of material, so it had a lot more resistance to it. Yep. That is our project.